I welcome you to my another video about electrician's tools. Today we are gonna have a look at Hioki Multimeter CM4375-50. I have also tested CM4141-50, but this one I have already returned to the official distributor of Hioki for Czech Republic and Slovakia, Teste. Teste, Testovací technika, is the company that keeps borrowing me Hioki multimeters for reviews. There is no money involved between us, and Teste doesn't claim any rights to adjust the contents of my videos, nor does it force me to say something or to not say something, or to do something or to not to do something. It's just free cooperation, for which I would like to thank them. I have been using the CM4141-50, the other model with bigger claws, for 3/4 of a year, and CM4375-50 for almost an entire year. And that was in the industrial cabinets, mainly power factor correction cabinets and measurements. The measured currents were usually between 10 to 140 AC amperes. The 4141-50, it has wider clamps and is AC current only, so it has a current transformer and is slightly more accurate and more sensitive. The CM4375-50 is a Hall sensor clamp meter, so it may slightly be less accurate on AC, but it can measure DC currents as well. The jaws of the clamps are narrower to fit in tight places. We are gonna show that. Both multimeters have the jaws conveniently shaped so they would attempt to sort out wires as we push the clamp meter into a wire harness or wire nest. It's actually much better than the old style clamp meters with a huge bumper in the front like that. That would catch onto just anything. Even when you are trying to get the clamp out of the set wire nest, it will just clamp to anything. It will catch everything. The 4375-50 is also more convenient compared to fork-style multimeters, as the jaws are thinner compared to the forks, and the instrument doesn't have so big error depending on wire placement inside the clamp. I mean, with fork multimeters, you must have the wire exactly where the arrows are on the fork multimeter, otherwise you can be few percents off. This closed-jawed multimeter fortunately is much less prone to this error of wire placement. If you would be also an industrial electrician like me, then you would say that an electrician really needs two clamp meters. One smaller for smaller wires, and one bigger for bus bars and multiple cables going into one instrument. And yes, that's true. So this one is actually mostly your smaller multimeter for the finer jobs. That would be approximately below 400 amps, but it is of course capable of 1 kiloamp. And lastly, there is also one more common problem, and that is when your power wires are zip tied together and you don't want to undo the zip tie. Then these thin jaws can slide between the wires quite easily, which is a property that I adore about this concrete multimeter. So the wire harness can actually remain as it was before your measurement, which is a huge plus for me. And to be honest, this is the only clamp multimeter that has this thin jaws that I have seen in my life, but I am sure there will be some other multimeters, but I have only met this guy. The packaging here is a little poorer, which is normal with industrial instruments, cause they are meant for professionals who would know what to buy based on their needs. This is one of separating points from DIY hobby multimeters that usually come with full set of leads and probes, so that the DIY hobbyist would have anything ready to use, so that they wouldn't struggle when using, let's say, inappropriate leads. But professional multimeters, they rely on user to buy additional accessories to serve his needs. We got here the instrument, well, of course. Then there is manual that is also available for download in PDF. And then we have Hioki L9300 leads, which are given to any Hioki multimeter of new generation. So multimeters like CM4141-50 or 4261, etc. The L9300 leads, just like Fluke TL175, will not allow you to lose your insulation cap as it is slidable and always on the probe. Personally, I like the mechanism of Fluke 175 more, but compared to Fluke leads, the Hioki leads have gold-plated tips, which is really expected for any multimeter above $100 US. Of course, gold plating doesn't oxidize over time, and leads will always have the perfect contact. Fluke, in the contrast, they have no gold-plated leads available, all of them are nickel-plated, or what it is, and they oxidize over time. So Pomona, that makes leads for Fluke, should really catch on this 20 years old trend and begin gold-plating the taps, as everyone has been doing for more than a decade. But well, since Fluke actually tends to stick to 40 years old mistakes and do them again and again, I wouldn't expect such a thing to happen. So the only option is to buy different brand leads for your Fluke multimeter. So you can buy these leads and use them with your Fluke multimeter. The Hioki L9300 leads can be bought separately for approximately $40, so you can have them even if you don't own a Hioki multimeter, and I must heavily recommend them. The cable is somewhere between soft silicone and harder PVC, and they are in the sweet spot, I would say. If you have a classic PVC insulation, then it may get hard to bend in freezing temps. On the other hand, pure silicone insulation is so soft and sticky that your leads would be prone to tangling and knotting. Not slip knotting, but knotting, just like wired headphones in your pocket 10 years ago. So Hioki really caught the sweet spot here, and that's great. The last thing I like about 9300 leads is the bend protection, aka bend relief. Most of the leads out there in the world have the release too hard, but Hioki relieves well. They are still harder than perfect, but actually softer than any competition. So they work best out of the competing ones. These actually work fine. So it's like, well, this is okay, this is not okay. So it's like one-eyed king between the blind plebs. Because all the other leads you are gonna get with other multimeters are gonna have this hard too much, even this end. Another accessory we get with this multimeter is batteries. The batteries are made in China, so don't ever put them in a Japanese multimeter. And we also get this case. It's a soft case with a zipper around, and there is one pocket for your stuff. In my case, that would be leads and spare batteries. As Hioki clamp meters only use 2 AAA batteries, and they chew through them like crazy. For example, when we were servicing power factor correction cabinets, the batteries in this Hioki ran out during measurements, and colleague who was using this Hioki was really upset that he now has to use his own clamp meter with classic jaws that don't penetrate well between wires. So I had to swap the AAA batteries between Hioki clamp meter and the other clamp meter, and colleague was happily measuring again. Now he wants us to buy him his own Hioki, and since then I carry spare batteries in this case. The case, to return to it, well, it is an ordinary case and there is nothing really great about it. Yes, it carries all the multimeter related stuff in one place, but it could definitely be better. Hioki could take a look at cases and make a hard case for their clamp meters, and the hard case could have like space for leads, space for spare batteries, and maybe some special probes as well. What is not by default on the packaging, but you can buy it separately, is Z3210 Bluetooth module that goes here into your newer generation Hioki multimeter, enabling it to communicate with your phone, tablet, or PC to perform data logging, THD measurement, saving measurements, and even creating PDF reports. When it comes to the multimeter appearance, the jaws can take one cable with external diameter of 34 mm or two same cables with diameter of 25 mm. Because different manufacturers and cable types have different insulation thicknesses, I cannot tell you the copper cross-section, but it would fit literally any 95 mm squared copper wires for sure. If we would be taking bus bars into measurement, then it's a single 60 by 10 bus bar or two 50 by 10 bus bars if they would be touching each other. So no space between them, touching each other. Cat 4 600 volts, we can trust the rating in this case. I mean, if you would have a Hioki multimeter, a Fluke, Bryman or UNI-T, but only for European market, then you can trust the CAT ratings. On the other hand, if you get a Chinese multimeter like Zoe, Habotest, FNIRSI, B-Site, etc., you shouldn't trust these ratings. When it comes to CAT 4 600 volts, then with these multimeters you can sniff around in a low voltage distribution room pretty much everywhere, even just after a big chunky transformer and before the main circuit breaker. With CAT 3, you can sniff around only after the main circuit breaker. CAT 2 allows you to only measure after small modular circuit breakers, like your 16 amp breaker for your sockets. 1000 amps, that's the maximum current the clamp meter can measure. The blue parts are made of rubber, and the gray part and the yellow parts are plastic, with the exception of the selector that is also made of rubber, and it has this beveled edge not to destroy your thumb after operating the instrument hastily. The selector runs nicely, slightly rubberish, and clicks into rotation positions just perfectly. The FN button is like a select in other multimeters. Holding it will zero your reading, which is usually done when measuring DC current or when measuring resistance. Hold is classic, hold, unhold, or AutoHold. If we would hold the hold button when turning the instrument on, it would turn off the automatic power saving. So it will hold on running. This is for backlight, and if we would hold both backlight and max-min peak at the same time, then the voltage readings would be multiplied by 2, as it is meant for high voltage probe, high voltage attachment in here. Then max-min peak activates statistical, let's switch to like DC, to statistical functions. We also get average here, which is great, and I personally use average more often than max or min. And hold the button to activate inrush measurements. Once again, inrush. They are quite similar to peak max. We are gonna look into this later. Then range switches ranges. Who would say that? And if you hold it, it activates a low pass filter, 630 Hz. We are now, let's go in AC mode. Filter. No filter. The sockets are classic 4mm banana made of one piece of material, as it should be. They are exactly 19mm away, so you can easily plug in any standard banana accessory. The display is classic LCD with pleasing neutral white backlight that has CCT 4600 kelvins and CRI of 80 RA. All that with the intensity of 350 lux measured at the display plexiglass, so the newer Hiokis are really doing very fine regarding the backlight. Readability from bottom is great, as it should be with any clamp meter, but the sides, well, they are worse. They are worse, and the plexiglass is here to blame, as from sides it looks like when you park a BMW over a waddle puddle and it drips some oil on it. The display has no bar graph, which isn't really needed in clamp meters, but we have here dual display with two values displayed simultaneously, which is a huge plus. As all Hiokis, even this one has 3 degrees of battery indication and is again set for alkaline batteries, so with nickel metal hydride batteries it just keeps reporting discharge battery, but it will work. And this gets us to the back of the multimeter and to the battery cover. Just like any Hioki, even this one has listed at least a few keystrokes for different functions, which is good to have written on your instrument and not have to search through your manual somewhere. Let's take the instrument apart. Here goes the cover. Here goes the Bluetooth. One battery, second battery. This is gold plated. We have 3 PH2 screws or bolts, maybe screws or bolts, something, I don't know. I don't remember that. Screws. Same length. And the third one. Same length. Great. So 3 screws are all the same. So this is the board. As we can see here, here we have this rim, which is great. It's protective rim. It goes around this inner rim. So definitely protection is great. Here we have gasket made of rubber. And these contacts for a battery, they are gold plated, as you can see. This is some luxury stuff. Yeah. Now into the instrument. As we can see, the jaws have its separate assembly that goes with this flat cable in the main board. So it's very precise, not like any other clamp meters that have like one wire going in here, second wire going in here. Let's just grab something. Third wire from here going like there. So they have it nicely going right here in the connector. Here we can see the battery terminals or connectors. And here we have some choke, so this must be a power supply part. There are 3 trim pots for some adjustment, I don't know. Maybe this multimeter is able to be adjusted manually. Maybe. Strange, really. Okay, here we have the connector for the Bluetooth. Here we have Hioki chip. They make them at home. Oh, this is nice. It's cut out. So the board isn't just one piece, it's cut out in here. These bolts, they have split washers, I would say. Most probably. Let's see if they are split. Or just classic. Yeah, split washer. Great. So this one is really not going loose by itself, only by screwdriver, which is great. Now here we have buzzer that beeps very loudly. In this case, it's not a fluke, so it's loud. Here we have PTC, some resistor. Here we have GDT, that's gas discharge tube. It's full of plasma if things go wrong. And here we have some resistor network, some capacitors, and it goes straight into the chip. So this is the innards of the Hioki clamp meter. I am not going to disassemble this further because, well, what do we see here? Well, nothing really special. So great. The innards, they look really great. The PCB is gold plated. To get statistical functions, we need to press the max min peak button, like in DC mode. So the instrument goes into statistical mode. Since now it notes every value. It can show maximum value that was in the display, minimum value that was in the display, or average. This is average of all samples it has already seen from the beginning. Then the game changers are peaks, peak max, and peak min. It's like max min, but much faster. As for example, when probing an AC voltage, let's say 230 volts at 50 Hz, the max function only shows the 230 volts, as it has been on the display. But peak max and peak min, they look at the voltage curve and gives us the peak max and the peak min. So that would give you approximately plus 320 volts and minus 320 volts. If we would measure peak max and peak min of DC voltage, it would catch some ripple, probably. When measuring current, we have the option to measure inrush by long pressing the button. Unfortunately, it's quite sensitive, as it triggers at 10 amps for more than 1 millisecond and cannot rearm, nor by any button presses or in the app. So you need to exit the inrush function and enter it again to reset the inrush trigger, which I find slightly inconvenient. The top value is the absolute peak value, so it refers to, for example, a short circuit electromagnetic trip mechanism in your circuit breaker. So, for example, if your Hioki measures top value of 20 amps and bottom of 10 amps, you can easily use a B13 or B16 modular circuit breaker. But if the values would be like 60 amps and 10 amps, I would use C13 or C16 MCB. When it comes to big chunky deionizing circuit breakers, they very often have all the trip shunts adjustable. What is great about particularly 4375-50 is that it measures both AC and DC currents, so here we can demonstrate the inrush on my cars. These scenes were recorded in Czech, so please read the subtitles. Tady je mínus, takže to je správně. Zde ji umístím. Nastavím ten inrush, jak vidíme. Ovšem, my to uvidíme, tady se nic nestane. My to uvidíme z kabiny, protože co? Protože máme připojený Bluetooth. Takže máme tady inrush. Tak jo. ISO si asi přidávat nebudu. Tak. Teďka schválně bez spojky. Si mi děláš prdel. Teďka ho musím. Takže ještě jednou. Ten inrush je strašně citlivý. Ale to je zapalování, takže z něj vylezu. Vlezu do něj znova. Tak. Cívka se budí 10 A, mou favorita, takže doufám, že to netriguje. Tak. Takže bez spojky. Tohle je špička, tohle to je potom takový RMS, řekněme. Zkusíme schválně se spojkou. Jsem právě zapalování, aby mi to nevzalo náběh, když naběhne řídící jednotka. A dáme inrush. Tak, teďka bude se spojkou. Takže se spojkou. No, čím dál tím podobný. Velmi podobný. Tak je tam hodně malý rozdíl. No jo. Zkusíme ještě oktávku. Tak zkusíme nejlepší český vůz 1. Takže zde zapnu inrush, mám to přímo na kabelu, co jde ke startéru. Máme tam inrush. Proč neběží ventilátor klimatroniku? Protože je nastaven na 2. Já ho vypnu. Takže schválně bez spojky, jo? Páne jo, to je dvojnásobek. No jo, 2 litr je víc než 1,3. Takže tohle je bez spojky. Zkusíme schválně se spojkou. Bohužel tam musím jít. Nebo nemusím. Tady není žádný reset. To musí opravit Japonci. Takže já musím tady totiž zase se musím přijít, inrush vypnout, inrush zapnout. Zkusíme. Není se spojkou. Takže se spojkou. Spojka. Tak schválně jak dobíjí při malých otáčkách. Teď to bude obráceně, jo. 6,4 ampér. Teďka mu zvýším otáčky. Úplně stejný. A altík, alternátor, ten má tady ten vodič. Ten nám dává 6 ampér. To není moc. No, moc taky málo žere. Filter is a function that sometimes is named differently, like VFD mode or low and then fading slope representing low pass filter. Activating this, the RMS converter in the instrument would omit higher frequencies from AC voltage or AC current. So this function eliminates any transients or higher harmonics from our reading. This filter applied means the bandwidth is 630 Hz, and without the filter, the instrument has approximately 3 kHz. The hold function must be present in any clamp meter, and that is because you often put the clamp meter in positions where you just don't see on the display. So you put in there, let it sit for a few seconds, then press hold, and take the clamp meter out to read the value. But there is a window for error. Have you waited long enough? Wasn't there a transient that you would catch and have false reading? That's where the AutoHold function comes to the play. Long hold the button to enable AutoHold. Blinking backlit button indicates ready and armed state. Oh man, how I love backlit buttons. I mean, it's so convenient, way to control something and indicate its status with just one element. And guess what? Oscilloscopes are full of backlit buttons, so yeah, this is the sole reason why I bought my Handtech, my Raiden, my Filek and my backlit mechanical keyboard. Backlit buttons, that's the deal. So anyway, let's see how the AutoHold works. We got here a few batteries, that's just for different voltages, that's all. Let's connect the leads. Now, when I connect it to the multimeter, it waits for the value to stabilize and then takes few readings, and if they wouldn't change much, it triggers hold with audible beep indication. So when you hear the beep, you can take the multimeter out and look at the display. Beep. If you want to measure any other value, then newer generation Hiokis can automatically auto-hold on a new value, which may even be very close to the already held value. Let's demonstrate. Let me take some other battery. It's very close. Now with correct polarity. And if you would be measuring some similar values very often, then to avoid potential confusion, I recommend rearming the multimeter manually. That's just a single press and it's rearmed. So for example, if you have a bunch of very similar readings, you can just measure the first one, rearm, and measure the second one. And you would be sure that there was another hold trigger between them. The continuity test, or buzzer, or beeper, or short finder, or just anything you call it, is the one fundamental function that every single multimeter must have, and it has to be implemented very well. A dysfunctional buzzer is a valid reason to stop using even an expensive multimeter, because the continuity check is all about response time and only triggering at low resistances. And of course, digitally latched buzzer is much better than analog buzzer, because in analog buzzer you often hear the scratching and you hear the changes in resistance. Unlike all the other instruments, Hioki multimeters have the buzzer as the first option on given selector position. So you move the selector to appropriate position and you are in the buzzer mode. That's it. You just rotate it. Rotate and you are there. 99% of other multimeters require you to press select at least once to switch from ohms measurement to buzzer, or from ohms to diodes to buzzer. Which of these do you use most often? The buzzer, the diode mode, or the ohm mode? The buzzer, of course. Actually, UNI-T has started to implement buzzer the same way not so long ago in their newest multimeter. What I absolutely adore about DT4282 and all the newer generation multimeters is the visual indication with red backlight. I mean, they aren't alone. I, for example, have a clamp meter that glows the display orange when there is continuity, but the buzzer response time of this given clamp meter is quite bad, and the buzzer is very silent. So now, let's see the response time and dual indication of Hioki. This response is absolutely the same amongst all the new generation multimeters. Absolutely beautiful. Now let's see the red backlight. Let me turn off the lights. You don't see anything, okay. The loudness is 61.2 dBA at 1 meter distance, so it's more audible compared to flukes, for example. And if there was much noise around you, you can still see the red display even from distance. This is how you implement continuity check. No mistakes made, no shortcomings, no room for errors. It's the perfect implementation. Diodes test is done the modern way in all newer generation Hioki multimeters. If your diode has voltage drop under 150 mV, then it recognizes a short and beeps. Beware, as some of the highest power low voltage Schottky diodes may reach just slightly under this threshold. But generally speaking, yeah, a diode with less than 150 mV is a shorted one. Let's see the voltage of this one. Yeah, 126. So it recognizes a short. It thinks this diode is shorted, but it's really only a very high amp and very low voltage Schottky diode with insanely low voltage drop. And it's not that. Yeah, let's see the other ones. Even less. Yeah. All of them are shorted. That's not the reality for sure. But well, these are somehow abomination things. So, well, let's take standard Schottky diodes. And that's something different. Let's actually hold it like a proper human would hold it. Yeah, 161. So now we have a good diode. This is between 150 millivolts to 1.8 volts. And anything over 1.8 volts would actually be recognized as over and blinking. That's all. This is a regular diode. What I find quite bad is that you cannot service any white LEDs. I mean, the white LEDs are very often serviced, as they usually may burn somewhere in a LED bulb or some fixture, and you want to take your multimeter out and probe around and find the dead ones. Well, they usually have a black spot indicating burnout, but still, it's always best practice to have your guess either supported or disproved by your multimeter. Electrician doesn't guess, electrician measures. So, the diode test, well, it's done well, but forget about any other LEDs than red, and don't measure ultra high current Schottky diodes. That's all. Other than this, it works perfectly with standard silicon diodes. Hioki multimeters tend to be quite on the faster side when measuring voltage. The newest generation always defaults to combined AC-DC mode, when the instrument would switch to either AC or DC based on present voltage. This feature is actually a foolproof way to ensure safety. as it has happened to sure many of you that you would be accidentally measuring DCV in an outlet, which is AC. My colleague, who is half a day older than me, so he should really have been really smarter, because he's significantly older, when he used his clamp meter of a different brand for the first time for voltage measurement, he too measured the voltage in DCV mode. And what was he probing on? He was probing on industrial 3-phase copper bus bars. That's an AC circuit, of course. So the first option, being the AC-DC mode, really makes sense, mainly for such an instrument like clamp meter that is usually used in industrial HVAC measurement. Pressing the FN button would then override to AC, DC, AC-DC, frequency, and automatic, which switches between AC or DC. Let's try how fast the measurement is. Let's try with the battery. 3, 2, on automatic mode. 3, 2, 1, now. Well, it finds the range quickly, but takes some time to integrate. Once more. 3, 2, 1, now. Same case. Let's have some smaller voltage. 3, 2, 1, now. Once again. 3, 2, 1, now. So it finds the range pretty quickly, but the integration time is slower. Let's measure the current, for which we don't need the leads connected, so let's leave them and have this a little. Okay, this is fine. Beware, when measuring ACA or AC amps, the multimeter measures up to 100 Hz. By using this instrument in practice in industrial environment, I haven't really found any problems or any errors whatsoever. For the instrument being in 0.5% class, I can say that it probably is, as it usually reports exactly the same values as our calibrated 0.5% analyzer. Unfortunately, there is no way for me to test ACA accuracy, as a reference source of AC current is somehow beyond the reach of any mortals, I would say. But DC current? Oh yeah, let's test that. I have here Hioki. It's a competing brand of Hioki. Okay, let's run through here some 1 ampere. That's very low current. 1 amp. We have minus. Okay, so it's like that. 1 amp. Let's switch to manual DC. 1 amp. Let's increase to 5. Oh, 4.9. Let's increase to 10. Come on. Let's slightly decrease. Okay, slightly increase. I don't want it to keep beeping here. So 9.99 is 9.9. Okay. And now, if we wanted to go beyond this current, approximately 10 amps, we would need to use, for example, this. The current will be multiplied by a factor of 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's make it 10. I wanted 10. Okay. Anyway, let's multiply the current by 9. Now, the current flows the plus. So plus goes here. So this is for positive reading, and this is for negative reading. Let's have it positive, stay positive. And now let's do like 2 amps. That would be approximately 18. 17, 9, 18. Let's do more. 3 amps times 9. Great. 4 amps. 5 amps. 6, 7, 8, 9, Let's turn it off. Let me just short this. Okay. So now this one is out. Let's go. 9. Now 10 amps, so 90. 99. Oh, I have set this power supply to not burn the fuse of this Hioki multimeter, so now we can increase the OCP to maximum of the instrument. So now 10 amps times 9, that's 90. Okay, let's go even higher, like 15, 16, 17, 18. Yeah, 162 amps. And if we would go like that, then it's minus. So this was the DC current. This is getting slightly warm. It's 2.5 millimeters squared, this wire. Now, this instrument is also able to measure power or display volts and amps at the same time. Kilovolt amps, well, okay, it is kilovolt amps or volt amps, but we really use watts for power. Now we would say, whoa, there is apparent power, of course. Well, the problem is we won't be able to measure AC power. As you can see here, it's only DC, 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 just DC, yeah? So this instrument is only able to measure DC power only. So forget about AC, about real power, apparent power, capacitive or inductive power. Forget about cosinus phi. It's just for DC. Let's demonstrate. I will pass through here 10 amps. That's 10 amps. Great. And let's put here some voltage. And the power would be 10 times 4.16. That is... okay, this is quite high. Okay, we need higher voltage or a higher current. Let's increase the current artificially by multiplying. That's a great idea I have here. Multiply by 9. Yeah, this is correct. And now let's pass the 10 amps through it. And now get the battery. Boom. It's still too little. Too little for me. I mean, we only have like 90 amps and 4.165 volts. That's too low. Well, I'm apparently not gonna fit this in here because the jaws wouldn't go around this or around this. This is proper 2.5 millimeter squared wires. But I have here some wire that may not be able to withstand some higher current. It's 0.5, I believe. Should be 0.5 millimeter squared. So if we pass some 10 amps through it for a short period of time, that should be really fine for a shorter time. But I suppose the number of threads here would be maybe even over 100. Let's just pass 1 amp through it, and by passing 1 amp we can measure the number of threads. Yeah, that's great, because who would count these? 1, 2, 3, 4, 5. You would sooner fall asleep. But you have this clamp meter, so you can put it like that, then start passing current of just 1 amp on off. It's 113 threads. It's 113, yeah, maybe. Okay, so let's increase the current to like 5. It's not enough. This says 1000. Let's increase to somewhere close to it, like 9 amps. Okay, 856 amps. That's great. That'll be some real high power. Okay. And now let's grab some voltage, something higher than this or than this. So by my hand, I have like this source of DC, like 21 volts approximately. Let's see the voltage. It's like 20.73 volts, so it's almost fully charged. And now let's see the high power. Okay, show me. Oh, 17 kilovolt amps, 17 kilovolts. That's great. So this times this is 17 kilowatts. Oh man, that's a really high power, I must say. And it's getting warm. I mean, slightly warm. It's okay. I'm passing 9 amps through 0.5 millimeter squared wire, so that's still okay. Won't melt. In my opinion, it would be great if Hioki clamp meters would be able to measure also AC power, including phase difference, and then in the mobile app show all the values for real, apparent, reactive and phase. This functionality would surely push the instrument even further. So fear not, we are not living in the dark ages. I have just decreased the ISO of my Sony Xperia 1V, which is also a Japanese phone, to ISO 32 to a better show. I could really have just decreased the screen brightness here. Could I? Mistakes have been made. So now let's see the Gennect Cross mobile app, which is for the Bluetooth functionality. I'm gonna turn on this instrument in like amp and now open the Gennect Cross app. We have huge Hioki logo, so you know what instrument you are going to connect. And now there was beep and this icon is flashing. General measurement. And so that you would believe me that it's really this one, let's turn some current on. Boom. 801 point something amps. 800 amps. Yeah, that's the reading from this device. DT4261 or CM4141-50. So all the other newer generation instruments, they also have the slot for the Bluetooth module, and they all, from the newer generation, can communicate with your phone. The module is sold separately and enables you to do some additional stuff on your phone or tablet, and it runs completely offline, so you don't need any internet connection, which is perfect. And the only connection you need to maintain is the Bluetooth one. From your phone, you can even generate reports. So let's browse through the app. We have logging, data logging. We can perform some data log, which is great. I mean, data logging, great thing. Oh, the battery has 2 bars. Okay, that is bad, because I have alkalines. They are gonna fall somehow faster. Well, for data logging, I mean, Hioki instruments are great for data logging, but the battery won't last. So do something about the battery, please, Hioki. Let's go back. We have comparator. You set some threshold, and then you can compare some values. We have a waveform FFT. Let's just stop the current. Let's switch it to AC mode. And I'm gonna provide you with some screenshots or some videos of this, because this is only for AC and I don't want to really play with AC on this desk, although I am industrial electrician certified by some checks official. But I'm gonna show you these measurements in the section with practical use, and this is where this instrument really bangs. What we have here, then we have event recording. Some of these instruments also support events, but that's for longer. Cloud monitor. Oh no, I am not going into any clouds. Actually, I want to do this, yeah, and this, yeah. No cloud. Solar string. What? Fault finder? It measures current? Maybe. I don't know how to operate this function. So yeah, there is definitely many functions in here in this app, and I haven't gone through all of them. But what I have definitely used, we have some data here. This is from one company. This is live to neutral, first, second, third phase, and this is L1 to L2, L2 to L3, and L3 to L1. Maybe? Yo, sorry, it's the opposite. So this is for L1 to L2, this is for L2, L3, and we can see here some THD values. So there has been fifth harmonic. Well, fifth harmonic is harsh on the neutral wire, seventh harmonic to 13th harmonic. So yeah, it's all the you call them odd numbers, these that cannot be divided by 2. So it's like for some square things like switch mode power supplies, like VFDs, etc. This is usually done by them. Fourth harmonic, quite high, okay. I have also generated some report from this one. So no internet, okay. Let's report, yeah, here. So this is report from some measurements, as we can see here. And this report was generated purely by this app. Here we can see starting current of my car. This also has been generated in this phone by this app, and this app can definitely run offline, apart from the cloud, of course. But it still works offline as it should, and you can as well take the PDF file and share it as PDF, include current time, for example, and share it just like that. So great, yeah. It's actually usable even without internet connection. As I am in no means and no official laboratory, all my reference sources or reference resistances are DIY class only. For voltage, I have my source of 5 volts, but it has managed to discharge the internal battery. And I also have this source for 10, 20, 30 and 40 volts. The instrument, the Hioki, didn't exceed 0.02% from value, which is by far much better than what it should be. For resistances, I have this mostly 0.01% resistance box, and for more resistance values testing, I was gifted with this Vishay 0.02% resistance decade, as the instrument had a maximum error of 0.13 from value for technical resistance values. It's surely accurate enough to fit its 0.7 class nicely. The other ones are capacities, but their measurement is very tricky, and actually even when I have a precise LCR meter, I cannot compare LCR meter gained values to multimeter gain values, because you don't measure capacitors with your multimeter, because the method is completely different. There is also temp measurement, for which I as well don't have any reference, but it measures somehow nicely. That's all I can say. One thing to think about, who would use contact type probe with a clamp meter? I mean, a clamp meter is really for some HVAC measurements on the go. So measuring temp with contact method seems to be more like a classic handheld multimeter field, because these usually stand on your desk and are stationary and measure something stationary. But clamp meters, they are for dangerous field measurements, and you wouldn't keep sticking the conductive probe everywhere. So I think they could even omit this temp function, but it's there. So anyways, this was almost enough for this video. It's now time for me to show you some videos from practice and to end this video. My thanks goes to Teste testovací technika company that lent me the Hioki CM4175-50, which I returned, and also this CM4375-50. They have not told me what to say or what to not say or what to omit. There was not even a trace amount of any force on me to distort or skew my review. So this is purely my experience, what you have seen here. Even one of my colleagues, who is from 1960s, and he doesn't really adore new technologies, he likes this clamp meter. He likes using it, as it is very convenient. Let's just quickly run through some positives and some negatives. First negative is the fact that the instrument is not sensitive enough for small currents, but this is because it has Hall sensor, so it's the tax we pay for the DC current capability. Second negative is the absence of NCV detection. Any clamp meter should really have NCV implemented. And ideally, if that NCV would have some scale in percents, because then you would be able to even accurately locate where the cable is that you don't want to hit with your hammer drill. Well, the NCV is probably not there because of the thin jaws, but still, if in future Hioki would manage to squeeze the NCV in there, that would be great. Because otherwise you would have to be finding the cables in the wall with your hammer drill. And well, we all know that if you have a huge wall, I mean 5-meter wall, and there is just one cable, you are surely gonna hit the cable. So this is the most precise way to find the cable, but it's sometimes better to not hit the cable with your hammer drill, and for this the NCV should really be implemented. Then there is third negative, and that is powerhouse. The mitochondria of this multimeter is twin AAA cells, which is absolutely normal in clamp meters, unfortunately. But hey, lithium ion 18650, I mean, I'll just grab here one of them. 18650, it has been a thing for last 20 years and more, and it has been superior option for last 10 years. This multimeter, is it modern, as it is smart, it calculates many things and has demanding backlight. It chews through batteries like crazy. So if there would be something to solve this problem, like a standard 18650 cell, that would be perfect, as the multimeter would keep measuring for over a week without needing for recharge. This thing has 4 amp hours. The AAA cells inside, they have 1 amp hour and lower voltage, 2/3 of this voltage. Then there is fourth negative, and it is price. This instrument costs about $550 excluding tax, which is quite much. Well, it's much compared to, for example, UNI-T, but UNI-T is one segment lower, as UNI-T is more like for hasty hobbyists or for some half professional use. Hioki, on the other hand, is for demanding professional industrial use. So if we would compare apples to apples, then Hioki is much cheaper than Fluke, so the price is actually not a con in the end. Fifth negative is just a small one, and that is the power measurement. If it would measure AC power and its related quantities, that would be just great. Now it only measures DC power, which is fine, is better than nothing, but well, AC power would really be great, mainly for power factor measurements. And that's all for the negatives. The first positive is the ability to measure DC current. The second one is that the jaws fit just everywhere. Everywhere where you can stick your finger, you can as well stick these clamps. Please don't try to stick your fingers where it is live, where there is voltage. The ability to measure currents and not be forced to take harnesses apart, that is awesome and saves much time and effort. Third positive is continuity check. It's just perfectly implemented. Period. No mistakes were made here. No mistakes. Fourth positive is the additional functionality like averaging, like peak max and peak min, like inrush current measurement, like THD measurement, like repulse generation from your mobile device. I mean, your phone just gives you PDF document, that's great. And there is other functions like AutoHold, like modern style measurements of diodes, etc. So that's the fourth positive. And fifth positive, the probes. They are great. The only tiny problem is that they aren't sharp enough for me, as sometimes I probe around in some old distribution rooms built in 1970s, and all the bus bars are already oxidized, and all the contacts or the bolts, everything is already rusted or oxidized. But you really want to penetrate the oxides layer, so that that's where sharp types come to use. But actually, I wouldn't use any of my fine gold-plated luxury stuff for stubbing these oxidized bus bars. I regularly use my ordinary nickel-plated probes that are cheap to replace. I wouldn't stub these with these expensive luxury stuff gold-plated. So that's all for this video. Please write in the comments your opinion on this instrument and also on this review. Takže 32,2, 31,7, 32,5.
Zkoukáš ty pojistky teda, co jsou udávané? PV 10.
Šedesát celý šest. 60,8. Takže RC1, 5, 75,9. Jo. No vidíš, tak byl opravený, ne? Tam je ten nový, ten, nebo není? 77,1. On spadnul z manuálního režimu? Jo, spadnul. Potvora. 77,1. A třetí fáze 76. Ty vole, to je na krev. Hele, on slítnul z manuálu do automatu, potvora. Výstupy. Testuj. Takže teďka chceme který? Šestku? Šestka je zrovna sepnutá. Můžu? Takže RC2. 68,8. 70,1. 68,9. RC1. Můžu? 51. Taky 51. 50,6.
Větrací dírky.
O. 62,0. 61,8. 61,5. 32,6. 7. 37. To hrozně lítá. 150 Hz. Tady mají velké harmoniky. 36. 32. Rovnou zvěřím harmonický. No, se sem nevejdu. Tak, druhá fáze. 0,25. To je proud do těch vybíjecích odporů. Případně nějaký unikající. Třetí fáze. 10,03. 11,61, 13,77, 11,6. Goodbye and see you in another video.